Hi, this video presents the Newton's second law of motion. The definition is given on the top. In short, it says that the body will accelerate in the direction of the net force that's acting on it. Whatever are the forces acting on the body, all those forces have to be reduced to a net resultant force. In this sketch, let's assume that the net resultant force of all the forces that are acting on that block are represented by the yellow arrow that you see there. One more thing, we assume that it's a frictionless surface, so there is no friction that's dragging the block back. With this, acceleration is force by mass. Let's look at the animation. The resultant force pulls the block towards x and the body is accelerating. It's not moving at a constant velocity. When we say it's accelerating, we mean that the velocity is increasing every instant. And the second law talks about acceleration. So whenever a force acts on an object, it accelerates the object. If an object is moving with a constant velocity, it means that there is no net force acting on it in any direction. And that's why it's moving with a constant velocity. So just to explain the vectors, force has got a magnitude, it's got a direction. As I said, the yellow arrow, so that's force. And acceleration is also a vector shown in this sketch here. So both the vectors are acting, of course, in the same line. The velocity too is a vector and it will act in the same line. Let's look at an animation. This is an animation of a graph. So what you see here is on the vertical axis you have the force, acceleration and velocity all on the same graph, and on the horizontal axis you have time. So the force is not changing. We applied a constant force. So the force is a yellow horizontal line. The acceleration is a pink colored line. It's not changing with time, so it's a flat horizontal line. The blue line is a velocity vector line, and because the acceleration is constant, the velocity goes on increasing every instant till the force is withdrawn. So that's the difference between acceleration and velocity graphs versus time. I hope that this was useful to you, and have a great day.